So understanding the deep technical details of blockchain is not necessarily relevant, I don't think, or appropriate for today's discussion, but instead I think exploring the basic principles of blockchains and the potential value that can be derived from the application of these ideas would be useful. And so essentially, if you picture a spreadsheet that is duplicated thousands of times across a network of computers, and then imagine that this network is designed to regularly update the spreadsheet, then you have a basic idea of a blockchain. And I guess what we have, therefore, is a database which is distributed so that all network participants will have a copy. No single participant would be in control of the content, but rather as all the parties broadcast changes to the database, a current state of truth is then established by the protocols on the network. This establishes consensus of what data is valid. Only once agreement is achieved across the network can the new truth state then be established. Each state change is then timestamped and permanently recorded in an ever-growing chain of records so that a fully auditable trail of states of agreement can then be viewed by all parties. So I like to compare this with the time machine screen in the Apple computers, because visually I think it gives a flavor of a sequence of states of now or previous states all linked together in time. So each state will have its own unique digital fingerprint, which is dependent on the content of the transactions at that state. And these fingerprints, called hashes, as you can see on the slide, any change in a transaction will change the fingerprint. And so for a given input of data, the output will always be the same. Although it's not possible to derive the contents from the fingerprint, it is easy to verify that the contents have been altered, because the fingerprint will not match that which is expected. And additionally, the fingerprint from each state is included as content in the subsequent state. So what this means is that alterations in one state will have repercussions further downstream and will be immediately visible. In practical terms, if a nefarious actor wanted to alter the record of any given transaction, they would have to alter the record on every copy simultaneously. And then they would have to ensure that the subsequent blocks in the chain are altered too, in order to keep a cryptographically consistent account that all can agree on, to therefore achieve consensus and a state of truth. And it is worth mentioning here that although there's different consensus mechanisms for different types of blockchain solutions, it's probably not the time to go into permission versus public blockchains. Although I do think it is important to say that there are degrees of decentralization and there are trade-offs between privacy, security, and scalability, depending on the desired levels of trust and functionality of the system. And so the level of trust and the number of parties in the network, amongst other things, will determine the choices of solution. Another fundamental component of some blockchains is their ability to run smart contracts. And for those unfamiliar with the term, a smart contract is a self-executing and self-enforcing computer program that executes the terms of a contract. Each copy in the network executes this set of instructions so that the consensus continues to exist that a task has been performed. And in theory, the complexity of these contracts can range enormously, as you can see, and can represent anything from a single instruction to a complete set of rules that govern entire autonomous organizations. When employed, smart contracts can be used to ensure efficient, unambiguous, and automatic execution of agreements, which can be viewed instantly across the network by all participants. So it stands to reason that this level of automation and clarity can speed up processes dramatically and at great cost savings. So to summarize the value, the value proposition of blockchains and the use of smart contracts, what the system provides is essentially a communications channel implemented as a peer-to-peer database, which allows multiple entities with diverse economic interests to collaborate where it is natural to cheat or seek advantage. And when presented with information, a participant can self-verify the content and author of a record, the state before and after the record, and whether the record is complete without addition or omission. And by creating a real-time, visible state of now that has been agreed across the network as valid, blockchains enhance transparency, reduce frictions, broker trust, improve security, and provide confidence in the integrity of data. And because cryptographic signatures are employed for each transaction, a full audit trail and greater accountability is achieved. And with no central point of failure, the system is always on and not controlled by any single entity. So the biggest question that companies may have in all of this is whether the investment is worth it. And at face value, I would say it would appear that there is enormous cost-saving opportunities from process automation and improved efficiencies. And the pharma supply chain has clear deficits when benchmarked against other industries. As we see in the slide, several areas have been identified where innovation may save billions of dollars. What is perhaps less apparent are the potential revenues from deploying such solutions. And it may be that companies can create market leadership through innovative supply chains, may be able to sell or license their blockchain as a service to others in the industry. Enhanced data integrity may bring with it new insights as well that generate new opportunities, particularly in combination with AI. Faster payments may also be possible via blockchains using native cryptocurrencies, and improved supply chain visibility may lead to recycling opportunities. A World Economic Forum report suggested that a blockchain may increase trade volumes by 15% and may increase global GDP by 5%. Though a large caveat I would say here is that stakeholder collaboration is essential for success. The technology is by design a tool for collaboration and permits trust to be brokered where it otherwise may not exist.